Okay, so let's look at our last example for finding the formula of a sequence. Yes, and with this type of example, we are also going to look at a different type of sequence. Now, let's look at the first one. Okay, so with this type of sequence, now let's make some observations. Now you see with the previous sequences that we solved for, you realize that the numbers are either increasing or maybe they might be decreasing, of which we didn't solve some yet. But I realize the numbers were increasing as it moved in subsequent terms. So you're having maybe 2, 4, 8, and so on. You're having 3, 6, 10, 15. The numbers keeps on increasing as you move up the terms. But I realize that with this type of sequence, all you are seeing is just two numbers. The first one is 5, the second one is 1, the third one comes back to 5 again, the fourth one is 1. So it's going to keep on moving to and fro like this. Now with this type of sequence, you realize that the terms are doing something we call alternating. Yes, the terms are alternating or they are oscillating. It means the terms will never go beyond 5 and 1. They would always be 5 1 5 1 5 1 till infinity. Yes, so how do we solve this type of problem, or what do we do when we face this type of problem? It's very, very, very simple. Now you realize that with this type of problem, the sequence is not like the other one, so we can't do for arithmetic or geometric or exponential. Rather, for this type of sequence, we have certain things we are supposed to know. The first thing you are supposed to do anytime you have what an oscillating sequence or an alternating sequence is to find the midpoint. Yes, is to find the midpoint or the midway. Yes, is to find the midpoint or the midway. Now, how do you find the midpoint of this? Very, 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 very what simple. Now I know that to find the midpoint, all you have to do, you know that you have your what your 5 plus 1 all over 2, which is going to be what 6 over 2, which is going to be equal to what 3. So this is going to be your midway, which means when you start from 5 and you are going backwards to 1, your midpoint is going to be what 3. The 3 is going to be the middle part of these alternating what terms. Now, after you found your midpoint, what's the next thing you are supposed to do? Now, the next thing you are supposed to do is to also remember that anytime you have an alternating sequence, there is going to be a constant value. So, alternating value. The alternating value is always represented by what? By -1. You have to know this. You will have to know this. Anytime you see that a sequence is oscillating between one value and the other, just know that there is going to be a -1 in the expression, because it's this -1 exponent something which is going to bring about these changes in what in values. So to solve this, now let's look at something. Now you have 5 and you have 1, and the midpoint is what is 3. Now ask yourself, what can you do to 3 to get 1, and what can you do to 3 to also get 5? Now the final answer is going to be very simple. You know that when you subtract 2 from 3, you are going to get 1, and when you add 2 to 3, you are also going to get what 5. Yes, so you know that the value that we are going to add or subtract is going to be what 2. So what do we do next? Now all you can do is what? First of all, write your midpoint. So your midpoint is equal to 3 plus bring the value you are adding or subtracting, which is going to be what 2. Now after bringing your value you are adding or subtracting, then you now bring your alternator. Now this is the most important part of this problem. Now after you've brought this alternator, now just look at something. If I solve this one just like how it is, so 3 plus, automatically we are going to get -2. 3 minus 2 is going to give me what 1. You realize that the 5 portion is going to be what lost. The 5 portion is going to be lost. So which means we are supposed to introduce a value of n, which is going to make us maintain the 5 and also maintain the 1, whilst n is what is increasing. Are we okay? So you can do your first try by saying when n, you only have n, what's going to happen? Now, when you only have n, which means when n is 1, let's see what's going to happen. So you are going to get 3 plus, now, negative 1 exponent 1. What do you think is going to happen? Let's solve. So when n is equal to 1, so you are going to get 3 plus 2 minus 1. Yes. So minus 1 and 1. Now you know that what? Any number exponent 1 is the same thing. So automatically we are going to get 3 minus 2, which is going to give us 1. When n is 1, the first term is 5. But when n is 1 over here, we are getting 1, which means what? This expression is going to what? Is going to fail. So what do we do? Let's now try when n is, let us now try n minus 1 and see something. So now we have 3 plus minus, we have 3 plus 2 minus 1. And when n minus 1 is the exponent. Now let us try this. So when n is equal to 1, what do we have? We are going to get 3 plus 2 minus 1, 1 minus 1. Because when n is equal to 1, we are going to substitute 1 over there. And what is going to be our final answer? We are going to get 3 plus 2, negative 1 exponent what? Exponent 0. Now, any number exponent 0 is going to give us 1, which means automatically 3 plus 2 is going to give us what? 5. Now, let us see when n is 2. Now, when n is 2, what's going to happen? So, we have 3 plus 2 minus 1. And when n is 2, which means 2 minus 1. Now, what do you think is going to happen? We are going to get 3 plus 2 minus 1 and what? And 1. Now, we are obviously going to get 3 minus 2, which is also going to give us what? 1. So, you realize that when the number or when the nth term is what? Is an even number, or when the n is even, we are always going to get the first value. And when the n is odd, we are always going to get the what? The second value. So let us try again for the third one. So when n is 3, so when n is 3, we are supposed to get what? 5. Now let's see. So we have 3 plus 2 minus 1. When n is 3, so we are going to get 3 minus what? Minus 1. Now obviously we are going to get 3 plus 2. And you know, since this one is an even number, we are going to get negative 1 exponent what? 2. Automatically we are going to get 3 plus 2, which is going to give us what? 5. So when n is 1, we are getting what? 5. When n is 2, we are getting 1. When n is 3, we are getting 5. When n is 4, we get 1. It is going to continue this process. So let's look at our final example for finding the formula of a given sequence. Then in our next video, of course, we are going to look at a limit and how to find the limit of a given sequence. Okay, so let's solve. So our solution. So the question is, we have 1, 3, 1, 3, and what? And so on and so forth. So in our previous example, remember what I told you guys? I said with this type of sequence, you always realize that there is going to be an alternating movement, or there is going to be an oscillation. This sequence is not like the previous ones that you realize that the numbers keeps on increasing as the terms also increase. Rather, the sequence is just bounded between 1 and 3. It's just changing 1, 3, 1, 3, 1, 3. So how do we do this? So you realize that I said anytime you have a sequence like this, first of all, find your midpoint. Find your midpoint. And obviously our midpoint is going to be 3 or 1 plus 3 divided by 2. And 1 plus 3 divided by 2 is going to be what? Is going to be 2. Which means our midway is going to be 2. And what's going to be our alternating value? Our alternating value is going to be what? Minus 1. Our alternating value is going to be minus 1. Now let's now look at what are we supposed to add or subtract to get what? The values to the right and left. So this is our 1, this is our 3, this is our midpoint. What can we do to get 3? We can just add 1 to the midpoint. And what can we do to get 1? We can just subtract 1 from the midpoint. So you know that what? the value that we are going to be working with is going to be what? 1. Okay, so how do we now derive the formula? You first of all have to write your midpoint down. So your midpoint is going to be 2 plus your value that you are adding or subtracting, which is going to be, let me write it, 1, having our alternator. Now, we are trying to see what value of n. Is it that when we put it into the function, we are going to get these outputs? So let's say when you raise this to the power n, what's going to happen? Now, when you raise this to the power n, let us try, because sometimes you have to try for n minus 1. Yes, you just make this quick guess. It is going to help you find the solutions very easy. So let's see, when n is equal to 1, what do we have? We have 2 plus 1. We have 2 plus 1 minus 1 and 1. Now, you obviously know that anything raised to the power 1 is the same thing. So you are going to get 2 minus 1, which is equal to what? 1. Now, let us see when n is equal to 2. When n is equal to 2, what do we have? We have 2 plus 1, negative 1, and we have what? 2. Very good. So with this case, what do you think is going to happen? We are going to get 2 plus 1. Now, anything raised to the power an even, or anytime you raise to the power 2, since the 2 is an even number, the negative is not going to work. So you are going to get the same what? 1. And eventually, 2 plus 1 is going to give us what? 3. Which means what? This expression is going to be what? True. Which means anytime you have what? When n is equal to 1, you are going to get your first term, which is 1. When n is equal to 2, you are going to get your second term, which is 3. Let us try for the last one, when n is equal to 3. When we are able to get this one, then it means our formula is correct. So what's the formula? 2 plus 1 minus 1 exponent n. And we said now n is equal to 3. So we have 2 plus 1 minus 1, and we have our 3. Now, we have 2 plus 1 minus 1. Now, since this 3 is an odd number, automatically this negative is still going to maintain its position. So we are going to get 2 minus 1, which is also going to give us what? 1. So when n is 1, we are getting 1. When n is 2, we are getting 3. When n is 3, we are getting what? 1. When n is 4, 2, we are subsequently going to get what? 3. Thank you very much. So in our next video, we are going to talk about how to find the limit of a sequence. Do not miss that video because it's going to be interesting.